Hello and welcome to this session. In this video, we will explore how to leverage timer modules in microcontrollers or other electronic systems to accurately tally external occurrences such as pulses, signals, or any other events.
Objectives. At the end of this session, you will be able to enter the program to perform the use of timer as an event counter to count external events and check the result through port 2 and record the observation. Introduction to timers and counters. 8051 has two timers or counters: timer or counter 0, timer or counter 1. Timer is used as a time delay generator. Clock source is the internal crystal frequency of 8051. 8051 timers use 1 by 12 of crystal frequency as the input of timers. Before writing the program, we will see the number of ports and the pins of the ports. The 8051 microcontroller has 4 parallel I/O ports labeled as P0, P1, P2, and P3. Each port is 8-bit wide and has a total of 32 input or output pins. P0 port 0, pins 32 to 39. P1 port 1, pins 1 to 8. P2 or port 2, pins 21 to 28. P3 or port 3, pins 10 to 17. Counter is used to count the number of events on registers. It has an external input from TX input pin X is equal to 0 or 1. We use TX to denote T0 or T1. External input from T0 input pin P3.4 for counter 0. External input from T1 input pin P3.5 for counter 1. Next, we will look at the tools and equipment needed to use of timer as an event counter to count external events. For this, you will need the following tools and equipment such as PC or laptop 1 number, microcontroller kit 1 number, USB cable 1 number, FRC cable 2 numbers, Flash Magic software, and Keel Microvision software. Let's now see the procedure for using a timer as an event counter to count external events. It involves 3 steps. Step 1. Write the program for 8051 microcontroller using Keel software. Step 2. Burn the converted file using Flash Magic software to the microcontroller IC. Step 3. Assemble the circuit by connecting the hardware parts and execute the output. Now we will run the program using the software called Keel Microvision software. Switch on the computer and open the Keel Microvision software. Once you have opened the software, click on Project and select New Microvision Project. Create the file name as per the project. Here, it is named as Timer as a Counter. Click Save to proceed. A tab pop-up appears to select the microcontroller. Here, we are using the 8051 microcontroller. So select AT89C51 from the database and click OK to continue. Click on No to add the startup.A51 to the project folder. On the left side of the screen, a tab called Project appears. Click on the plus sign beside Target 1. Now Source Group opens. Right-click on the Source Group 1 and select Add New Item to Group Source Group 1. Select the .asm file since we are writing the program in assembly language. Name the file. Here, it is named as Timer as a Counter. Click on the Add to add it on to the Source Group 1. Now start entering the program in the .asm file created. org00h. Set origin to address 00h for starting the program memory. Move t mod, /60h. Set timer 1 mode to mode 1, 16-bit auto reload. Move th1, /00h. Initialize timer 1 high byte to 00h. Move TL1, /00h. Initialize timer 1 low byte to 00h. Set B P3.5 semicolon. Set bit of port 3 5th pin, 15th pin of the IC as the input port and pin as the input clock pulse. L1 colon set BTR1. Create label L1 and set the bit of timer 1. L2 colon move A, comma TL1. After setting the timer 1, create another label L2. Move the value of timer 1 low byte to accumulator. Move P2, A. Move accumulator A value to port P2. When there is an external pulse by the input port, the value will be displayed by port 2 in the form of LEDs. JNB TF1, L2. Jump to label L2 if timer 1 overflow flag TF1 is not set. CLR TR1. After performing all the actions, clear timer 1, run control bit. Stop timer 1. CLR TF1. CLR means clearing timer 1, overflow flag TF1. SJMP L1. SJMP means short jump to label L1, loop back to start of the program. End. Type end to end the program. Now navigate to the target and right-click and select Options for the target 1. Change frequency to 11.052 MHz. Select the box of the Use on Chip ROM. Now go to Menu and select the output. Enter the hex file name in the name of executable. Here, it is timer as a counter. Select the box of Create hex file and click OK to continue. Navigate to the menu and select Translate and check whether there are any errors or warnings. In the build output, it will show the number of errors and warnings. Now next to Translate, there is an icon named and click on the build target. In the build output, it will be displayed creating hex file from timer as a counter. Timer as a counter, 0 errors, 0 warnings. Turn on the microcontroller kit after entering the program in the software. Now connect the laptop to the microcontroller kit using USB cable. Connect one end of the cable to the laptop and other end to the microcontroller kit. Now click Windows on the keyboard and type FlashMagic to burn the code. Now in step 1, select microcontroller. The microcontroller specification will vary from kit to kit. Here, we are using 89V51RD2. Now for selecting the COM port, click on Windows and type Device Manager. Navigate to ports COM and LPT and check the port number. Here, it is COM19. Now open FlashMagic, select COM port as COM19. It varies from kit to kit. Select baud rate as 9600 and interface as None, ISP. Click on the box of Erase All Flash to erase all the programs previously done in the kit. Now go to Step 3 Firmware and browse the hex file created and select the hex file. Navigate to Step 5 and click on Start. Now click on the Reset button in the microcontroller unit to dump the program into the kit. Now locate the external push button and see the pin number of the IC in the microcontroller kit. Here, it is connected to pin 15 of the microcontroller kit. That is, it means port 3, 5th pin, that is timer 1. Connect the ports according to the program. Locate the ports, switch and LED in the kit. Use FRC cables female to female for connecting the ports.
Here port 2 is connected to the LED. Connect the port 2 to the LED.
Now click the Reset button to start the program burning in the kit. Navigate to the external switch and give the external clock pulses by pressing the switch. As we can see, when the switch is pressed for once, the LEDs will be in 00000001 state, indicating the count of the clock pulses. Continue by giving the external clock pulses and see the change in the LED state. As the clock pulses increases, the LED will be changing. The maximum we can give is only till 11111111 FF.
This brings us to the end of this session. In this session, we have learned programming the timer as a counter for counting external events and Design the timer as a counter for counting external events using the 8051 microcontroller. Thank you for watching. We will see you in the next session.